So welcome back again once again. So we wouldn't waste much time, but basically what we have to talk about in today's class would be databases, right? Databases. Okay, so I think this is the last concept that we need, or that is available in the curriculum. So once we're done with this, then basically we need just to see how we can move from our local machine, how to move our endpoint from local machine to a cloud where external bodies can currently send this request and interact with it. Because so far, we've only been interacting from one end. So basically means that if I need to interact with your own source code with your endpoints, you have to somehow send the entire source code down to me in order for me to interact with it. Okay. Hopefully that should not be the case after this particular concept. So we should be able to put this out there for people to actually use. So this is what we're talking about in today's class. So please, there is no slide. So please just start immediately. Okay, so this is what we're talking about: databases in Fast API. In Fast API. In Fast API. So I have my VS Code open here, and I also want to assume that you know what needs to be done to arrive here, right? So I have my virtual environment turned up there, and I'm currently in the app folder, which I will move one step behind because I had to move to an app folder so that I can open it in VS Code from terminal. But after this, I have to go back one step behind. So remember that due to how we converted this entire folder to a single package, we can no longer execute from inside of that app folder. So you have to move one step behind and execute our UV con from outside the package itself, right? Which we talked about in our previous class. So at this point, I want to believe that we are all on the same page and we can dive straight to databases, right? I believe you guys can hear me, right? Please, let me that you guys are hearing me properly, please. You guys are hearing me, right?
Yes, we can hear you, Mr. Basin.
Okay, fantastic. All right, so let's continue. Databases in Fast API. So far, we've been dealing with. So far, we've basically been saving things to either dictionary or JSON file, right? As the case may be, or text file, right? But in actual sense, those are like file systems, right? File systems are likely to have memory loss. So basically, what that means is that in situations where you fail or you forget to close your file, what happens is that there's a tendency of losing the content of those files, right? So file system or files is not necessarily or it's not recommended for storing information or data. Okay, so databases is always recommended. So as such, as backend engineers, you cannot run from it. You cannot run from it. So for definition's sake, a database is basically an electronic means of saving and organizing data for efficient retrieval and manipulation. So let's just take that down. So database is an electronic because just saving it electronically, right? So it's an electronic means of storing data for easier retrieval. I would say for easier manipulation. So manipulation here actually covers the retrieval and everything, right? For easier manipulation. That's basically what database is, right? So it's an electronic means of storing data for easier manipulation. So and then we have different types of database. So we have the relational database, right? Database. We have NoSQL database. We have NoSQL databases, right? Because and then we also have OOP. Sorry, let's see. Object-oriented databases, right? Yeah, object-oriented databases, right? And so on and so forth, right? So there are different kinds of databases, but for this particular class, we are going to focus strictly on relational database, right? On relational database, right? So this is the most commonly used database, right? So each of these databases has their own purposes and their use cases, right? So for our own case, right, a relational database fits in the most as it's a kind of database. So this one is a type of database, right? It's a type of database that stores data in tables, right? So basically, information is being stored in tables. So it's similar to spreadsheet, right? But it has a lot of features. So spreadsheet can never be database. It has no comparison, right? Though relational database and spreadsheet have a similar attribute like storing things in a tabular form, right, in rows and columns, right? But database as it whole has its own special features. For example, this man here has the features of relationship, which we will talk about, right? But basically, I want you guys to know about that database is basically what an electronic means of storing data for easier manipulation, and we have different types of them, right? And for this particular bootcamp and this beginner track, we're focusing on relational database as it's a type of database that stores things in tables, right? So information have been arranged in tabular forms for easier manipulation. Okay, so and we have different types of this relational database. So you're beginning to see how these types now move from database types to types of relational database. So a typical example is we have I believe this one is all we've seen this one before. We have my SQL, right? So this is a popular one that I believe all of us is aware of. So my SQL is a type of relational database, right? And we also have another type, Postgres. Postgres QL, right? So this is another type of relational database, and we have this other one, SQLite. So SQLite is more like a file database, but it's a type of relational database. So my SQL and Postgres is mostly recommended for production. So it means that if you are going live, we will likely use any of this type of relational database. But during development like this, we will mostly be using SQLite. So SQLite is a file database, is a file relational database, right? So that means you can basically just see this database as a file among your list of files that we have there, right? So you can have that among them. But then this one is not safe because it can easily be deleted, right? So you can mistakenly at some point during development, you can just mistakenly delete that file out. Okay, so and this one doesn't really have strong retention memory. So things tends to always get missing in this particular database, right? So that's why it's not even recommended for production, right? So they'll tell you use this one for what? For development, and then when you're ready to go live, right? So you choose any of this, right? But for this bootcamp, we use Postgres, right? And one thing that you should know again is that all these databases understands SQL, right? SQL is, I believe, we've all heard of it before. So this is the language, all right, that relational databases understand. All relational databases understand what SQL, which is structured query language, right? But then you'll be wondering, are we going to pause on Python and then move to learn SQL, and at some point come back to continue with Python? No, that's not going to happen, right? We don't have to pause and go and start learning SQL in order to interact with these databases, right? But then we will use what we call ORM, right? All right, object relational mapping. So let me just put this their meaning there so that come back and refer. So this is object relational mapping, right? So for most of us that have heard of object relational mapping before, or for those that haven't heard of it before, it's basically a technique, right? It's a technique that allows us to interact with relational relational databases with a high level programming language, with a high level programming language, with a high level programming language. All right. So basically, what do I mean? It means that with ORM or with this technique, right, we can basically interact, right? Interact with these databases without necessarily doing what writing the pure SQL, right? So basically, what happens is that when you write your high-level programming language like classes, right, right, that classes can be mapped to an equivalent SQL syntax, right, which this database will simply understand and carry out whatever operation that that's used, given it. Are we making sense? Are we making sense? Are we correct?
Yes, sir.
All right. So that's basically what we'll be doing, right? So we'll make use of this technique, right? And then we interact with these databases, right? So for this production, right? Sorry, for this development phase, for this particular class, we'll be using SQLite, but I'll also show you how we can get PostgreSQL, because the thing is that once you go live, everything about it should go live. Your database should go live, your factory should go live, your source code should go, basically everything should go live, right? So, but then you'll be wondering, how do we get the live version of PostgreSQL or this database? So there's some platform, right, that give these databases for a paid amount. Okay, but then there are also platform that give these same storages on a free how do you call it, free mode, right? So basically there is a limit, and trust me, that limit is enough for us to use for this particular project. So I'll show you how you guys can get the live version, or should I say the online version of Postgres, right? And I'll also show you how you can set up your SQLite for development. So maybe we can write some if-else statements to switch between this database depending on which environment that we are. If we are live, then use the live the Postgres from a trusted server. If you're local, then we can use the SQLite for development and so on and so forth. Right? So that's basically what we'll be doing in this class. And let's just kickstart into practical, right? So that's basically all for notes. If there's any other note, I'll come back and add it. All right. So please just put that in mind that that's exactly what databases are, and there are different types of them, and there are also different types of relational database. So please, I think some people actually conflict this man. Most people say that most people say that this man is also a database. Please, SQL and MySQL are two different things, right? SQL is a language that MySQL understands, right? SQL is a language for relational database. MySQL is an actual relational database type, right? So please put that in mind. Don't conflict that, right? Don't conflict that. Do not conflict that again, ever. Okay. So let's see. Let's dive into coding. Let's dive into coding and let's see what we can do. All right. So first of all, we need to one more thing. All right. So there are different Python. Okay. So I think every language, right, comes with this model, right? So they are libraries, right? So they are basically libraries that enables us to use this ORM technique, right? So for Python, we have about 3 of them that I can think of right now. We have SQL model. We have SQL Alchemy. For those of us that have heard of it before, SQL Alchemy. All right, Alchemy. We have Django ORM, right? We have Django ORM. So Django ORM here is specific for Django. So Django is a web framework. Is a Python web framework, and it comes with its own inbuilt ORM. So this particular ORM here, is tied to that particular framework. So we cannot use this. Then we are now left with these two, right? But SQL model, right, is built on top of SQL Alchemy, making SQL Alchemy more heavier compared to SQL model. So in that case, we'll be going with SQL model. So this is the library that what the hell. So this is the library that we will use. Okay, sorry about that. This is the library that we would use and do what and make and carry out this technique of interacting with relational databases while still maintaining our high level programming language itself. Okay, so that's basically what we need. So in that case, we need to do what we need to have SQL model installed, right? You have to have that. You have to have this library installed. So both SQL model and SQL Alchemy, they are a standalone library. So it's not tied to any framework, right? So you can still use SQL model even in Django framework, right? But then what would be the point if Django already comes with its own ORM, right? But basically, what I'm trying to say is that both SQL Alchemy and SQL model are standalone, so it doesn't they are not tied to any framework. So as such, we can use them in Fast API. But even when using them in Fast API, it doesn't really mean that they are Fast API dependent. We're simply just importing it and using it. It's similar to the JWT password hashing library and rest of them, right? So each of them are standalone library that can be used within any Python project. Okay, so let's go ahead and let's have this model installed, and this model is essential for us to do what to communicate with our database. Okay, so for more detail about this particular library, of course, like I said, all these libraries that we've used, all these external libraries that we've used, if you need any detail about them, you can always look them up. All of them have their own documentation, and like I said, every third-party modules or packages have their own documentation, right? So don't think that there's a law somewhere that says that if you install any third-party module, that you must know how it's being used, right? So every third-party module, you can always go online, right, and go and Google about it. So for instance, if I need SQL model documentation, right, so you can always come here and see the details of SQL model. So there it is, right? So there's user guide there, so you can even click on it and do what and use it. So this particular library is actually built by the people that built Fast API, right? So they made a lighter version of SQL Alchemy so that you can integrate it with your Fast API. So if you look at this URL here, we have a SQL model.tiangolo.com. This same tiangolo.com is similar to what we have with Fast API. So if you go to Fast API, you will also see the same tiangolo.com there. So yeah, the same set of humans actually built those two libraries, right? So let's go ahead and let's go and continue. All right, so let's have this man installed. So please just keep in mind that you can always come in here and look at this man. Same thing with which other library we use JWT. The JWT as well, JWT documentation. You could also see its own documentation, so you could always see there. So you can always come here and look for more details about those libraries, right? But because as you would likely not cover everything in the documentation compared to what we are doing with Fast API. With Fast API, we are basically covering everything in that documentation, right? But then for other external libraries, we just cover the part that is essential to the class, right? To the class itself. Okay. So let's have this man installed. So to install SQL model, you simply just say pip install SQL model. So that's it. So pip install SQL model. Pip install SQL model, and this should have SQL model installed. All right, so one more thing that you also want to install, because remember I said that in this class, we look at how we can hide our secret keys and important document that we do not want to push to GitHub, because for you to deploy your project needs to not stay in your local machine, right? So to push your project to GitHub or to a cloud server like GitHub, then certain credentials should not go alongside with it, right? And they should be maintained in a specific file, but not just in random file. They should maintain in a specific file, so that when you are deploying, the deploying server itself can simply locate that particular file, right? You can simply locate that particular file. So we're gonna see how we're gonna do that. And the library that we're gonna use for that is going to be Python.env. So just go ahead and install that as well. Okay, hold on. I think this is installing certain things. So you can see that we are also installing SQL Alchemy. So like I said before, SQL model is built on top of SQL Alchemy. So that means we somehow need SQL Alchemy for SQL model to work, right? So both of them are kind of tied. So I think it's downloading, but 2.1 MB is downloading like God. All right. So while that is coming up, please also know that we will also install Python.env module for hiding of essential credentials. Okay. While that is still installing, I also want to believe that all of us in this call are on the current stage, and we are working on our final project. I believe you guys were on attending the onboarding of how the capstone project will be like. Okay, so please make sure and wrap up on time. Hopefully, before Monday or so, you guys would be segmented into groups and so on and so forth. So the standard of CodeCamp, right? So you may be lucky. They may put this guy together. What's the name? Gabriel and Sato. Yes, two of them like completing man. Two of them sound like one person. So luckily they can put the figure together and they can carry me with it and can add with what's her name? I can't remember it. But well, the separation will be. I'll make sure that those two parties don't stay well. All right. All right. So for some reason, this man is taking a lot of time. Okay. What that is taking time. Let's just go ahead and proceed with certain configuration, right? With certain configuration, then we just come back and use it whenever it's ready. So what are the configuration that we need? So we are gonna go back to our database setup, right? So this is where we need to put everything in place. Right. So what are the things that we need to put in place? So first of all, we need to create a database engine. So by creating a database engine, I simply mean connecting to the database, right? So the database is somewhere. We are assuming there is somewhere, and we somehow need to do what to connect with it. So by default, if you create a database, they'll give you credentials. Okay, and for the online version of database that we'll be using for this or for CodeCamp, the online version that we'll be using would likely come from the online version will likely come from maybe we can consider using there's render. Render also gives a free version of database, so you may also need to actually consider signing up for on render, and we may also need to use Superbase. Personally, I would want to use Superbase because render actually has a limit. So for render, they will give you, I think, 1 gig of free database, but it will only span for 60 days. But this other one will give you the same 1 gig with no limit. All right. So basically, it means that you only stop using this database when it has filled up. Okay. But render on is whether it's filled up or not. 160 days to delete the database. So it's yeah. I would personally I would go with Superbase, right? I will go with Superbase. Well, I could just create I will show you guys how to go about creating your Superbase account, right? So it's very simple, right? So Superbase also gives room for both database and storage. So I think I have one to my account here, right? And for the free version, you can only have 2 projects at a time. So I'm not sure that they can allow you to have more than 2 projects at a time on a free version. So you can see I'm actually on a free version. So maybe when you migrate to a pro version, then you can consider having multiple projects. So one project would handle both database and storage. So you come back and we create accounts with Superbase, right? And we use it for that. So what again do we need? So we may likely not use this man. So we have to take that man out. Let's go and see if our stuff has finished installing. There's an error for some reason. There shouldn't be an error. It looks like network error. It's bad. All right, let's Okay, so when Superbase gets filled up, I think you get notified that it's filled up. But at that point, you have no choice now. You have to where you can either create another project, right, and create another database, or you can just come and pay for the provision. But once it's filled up, they will not wipe your data. Render is very funny. Once it's filled up, the thing that I think they'll give you is it 7 days grace to come and either pay or come and move your data to some other place or retrieve it or download it. They'll give you so many options, right? But after that days of grace, they'll delete it up alongside with your data. All right. So while we are still roaming around is because we're waiting for this man to install. Okay, we're waiting for this man to install. All right. So, but then there are certain configurations that needs to be put in place, right? There's certain configuration that needs to be put in place. So with SQL model being installed, we can do what? We can start writing our high level languages that will do what? That will represent what or that will have an equivalent SQL syntax, right? So basically, what we write our normal Python code, and with the help of SQL model, that will do what? That will automatically convert that man from our high level programming language to an equivalent SQL code that will somehow do what? Write that or carry out that operation on the SQL model itself. So let me see if I can write that step. So when we replicate our tables using our high level programming language, right? Our high level programming language, and then we can do what? And then with the help of SQL model, this will be a map, or because that's basically what happened. It does the mapping. So this will be mapped to what? To an equivalent SQL syntax, right? Which will now carry other operation on the database itself, right? So that means that this database have to be connected, right? Because if it's not connected, then where will the mapping now happen, right? So we have this man needs to be set up, and this man needs to be set up, right? The tables here needs to be set up, right? And the database needs to be set up. Then whatever happens in between is what is handled by SQL model. Is that understood? So that's basically what will happen. So let's see again. All right, so I think that has finished downloading. So it's simply installing. So it's installing Greenlet, SQL Alchemy, and SQL model. So like I said, the model is built on top of the Alchemy, right? But we won't be using the Alchemy, but we're using the model. That's basically what we use. So this is what will happen behind the scene, right? So this tells us a ton of stress of going to write a lot of SQL syntax, right? Though SQL syntax are very simple to write and quite straightforward, right? But then let's just proceed with the ORM, right? Let's just proceed with the ORM. But there's also a means of writing your pure SQL syntax in your Python script, right? And then you just pass it to, I think there's a module that translates SQL. There's a Python model that translates SQL. So if you're a lover of SQL syntax, right? There's a means of doing that. There's a means of explicitly writing those SQL syntax. Very easy, right? But you won't go into that in this particular class. But just for knowledge sake, you can always look it up. There's a library that does that configuration. Okay, so let's go and see what we have. It's still installing. Okay, still installing. All right, so first of all, we will create our table, right? And then we come back and connect the database. So let's go to table. Where will the tables be? So if router is for all our endpoints, right? And schema will likely be for maybe schema will likely be for data validation, right? And CRUD will likely be for database interaction, right? And then after that, we could do so. I think let's just change it from table to database interaction. So database interaction. So this should be DB interaction. So by DB interaction, I simply means we can either create table, we can either edit something from existing table, we can delete, we can update, so all those things we consider what as database interaction. Whether you are creating a table or you are deleting a table or you're updating something in a table. So that should all be considered database interaction. So that will be done that interaction will be done with our high level language itself, and from there SQL model will kick in and take care of the rest all the way to our database. Okay, so what again do we have? Let's go back and let's confirm that this one has been installed successfully. For some reason it's still installing. All right. Okay, so let's go ahead and let's see how do we create them? Because remember I said about that database, right? Or relational database, they store things in tabular form. So it means that if I need to save a data, I need to have table already in existence, right? So I am saving things to a table, right? Or I am interacting with a table in a relational database. That's how relational databases work. So everything is done in a tabular form. So it means that before I can retrieve, update, delete, or get something, that thing needs to be in a table, or there must be a table that already exists somewhere. So far we don't have any table, right? So that means we have to start creating tables. And to create tables, I want to create a new folder, and this folder I'll call it model. So model will represent all the tables that we have in this project, right? All the available tables, all the tables that we will ever have in this project will live in that model folder there, right? And as usual, because since we want this folder to be seen as a sub model, as a sub package to the main package app, right? I have to come in and add what underscore init underscore dot by, right? And from there I can start creating my file. So basically I can create a new file here, and this file I'll call this file user underscore management, right? So this file here would be this particular user file management, right? Would basically be for all the tables that pertains to that will pertain to user management, right? All the tables that will pertain to user management. It could be the user table, the OTP table, and so on and so forth. Now all those things will live and you stay in the particular file. And maybe if I move to blogging, then I have another file called blog, and every table that relates to blog will stay in that particular file, and so on and so forth, right? So that's basically what will happen. Right? That is basically what will happen. Okay, so let's go back and let's see if we have our man already installed. And it's still installing. I don't know why it was installing, but it's still installing. It shouldn't be taking that long. It shouldn't really be taking that long, sincerely. Maybe I should have this installed before the class. It shouldn't be taking that long. The files are pretty small. We have just about 2.1 MB of file. To install a 2.1 MB file should not really be for some reason it's taking much time. All right, so we're waiting for that. So once we have SQL model available, what happens is that we want to make use of remember SQL model is what we will use. But close this man off. I have to come and start all over again. So I can't come this far. Closing it again. But at the same time, closing it might also work. But at the same time, it may not also work. This life is very fun. But let us give it a few more time. Maybe it will get installed, and it doesn't, can come back to it and start over again. All right. So, but then once we have our SQL model installed, now what we want to do now is to start using that to create table. So how do we create table? So the thing is that the way Aquarium works is that it maps your classes, right? So remember that those classes that we talked about during our Python days, right? So it's written around. We are gonna create that same class that we create for Pydantic and the rest of them. So, but this time around, instead of inheriting from base model, we inherit from SQL model. That way, SQL model now knows that this particular class should be mapped as a table in a database, right? So it will do what it will when you now execute your code, because that particular class inherited from SQL model. What happens is that it will automatically write the SQL model for creating a table, and that will automatically create that table in your database, right? So it's that simple, right? It's that simple. So the mapping is very easy. So it mostly what is mostly yeah, so I think I have it already installed in another. That is true. Let's see. I think I have it already installed in another better environment. I think so. Yeah. So please, wow, wonderful. But probably finished. Maybe it was just lagging. I don't know why. At most times my phone is lagging. So it's finished. But you can complain that by saying pip freeze. Pip freeze tells you everything that you have installed so far. So with pip freeze, we can see we have SQL model. So there it is. So we have it installed. So we are good to go. All right. So let's go back and let's continue. So I was saying that basically what happens is that, or how does SQL model works is that it will map your Python class to an equivalent table, right? So now if you create a class that inherits from SQL model, once you specify that let SQL model see this class as a table, what happens is that once you execute your script, SQL model will automatically write the equivalent SQL syntax for creating a table with columns, right? So where each attribute of your classes will represent a column of that table. Remember, relational databases save things in or interact with interact with data in a tabular form. So it means that the table has to exist already in order for us to start interacting with that table. So this is us we're trying to create that table, and creating of table will always happen in the model folder. So the model is our table, the schema is our violations. Please don't mix that up. Model is for table, schema is for violations, and then CRUD is for database interaction, right? So let's go ahead and let's continue. So how do we use this? So we simply just say from SQL model, right? SQL model, right? That man there. We want to import field, right? You want to import field. Hold on. We want to import a field. Apart from that, apart from field, we want to also import this. This is the main thing. We want the SQL model itself. So this is the class. Let's see, import SQL model. So this is the class that does the whole magic, right? So this is the main man that does the magic, right? So all your tables that should be mapped as all your classes that should be mapped as a table in the database needs to inherit from where? It needs to inherit from that class called SQL model, which somehow lives in the SQL model package, right? So it's similar to Fast API, where Fast API lives in the Fast API package, right? So basically, from this we can start creating our table. That's simple. So I can just simply come here and say class, right? So let's say I want to create a table called a user, right? The user table, right? And then so basically what happens is that this class has to inherit from where? From SQL model. From SQL model. And then should also carry an option of saying that this is a table, or this should be considered as a table. So yeah, I would say table should be equal to what? 2. Right? So here I'm saying that after this inheritance from the SQL model, which help in mapping this class to an equivalent SQL table, should be seen as an actual table and not our normal Python classes. So it means that once we execute this thing, right? So what happens is that first SQL model will go through your entire project and look for all the classes that has table equals to what? True, and do what? And will write the equivalent SQL model for creating those tables. So that's basically what we are basically just putting there in that inheritance there. Okay. Then after that comes our colon, and then within here we can start giving our class attributes, right? So this class attributes here, would be automatically would be seen as the column between for that particular table. So here I could say that this particular table should have let's say a first name, first name. So this attribute here, what we map as a column for first name, right? And the good thing is that this on under the hood, SQL model still uses Pydantic for violations. So if I come here and put my typecasting, right? I'm sorry, my type hinting, it still works, right? It still works. So that is just the beautiful thing about SQL model. So it all under the hood. Pydantic still comes in and guide out violations, right? So your table here will always likely, right, to look like the ones in your schema. So not router. We always resemble the one in your schema, right? The difference is that one inherits from base model, the other one inherits from where? From SQL model, right? So let's continue. So I can have last name. Last name here can be what can be string as well, and I can have email. Email here has to be email string. So let's go ahead and let's do that one in. So you can say from SQL, from Pydantic. Right, you want to import email string. This should be email string, and maybe you can have password. And then password here can be string as well. All right, I think that is all that. Okay, but then one more thing again is that one more thing that I love doing is that I always like to have an ID, right? An ID, I usually see ID as a unique identifier for my record, right? So each record should have ID, where the ID should be a serial number, right? So it should be a serial number. So where that number will signify what is a particular record. I believe that in Excel, this happens as well, right? So each record should have a unique identifier, right? Except you don't want it, right? But I don't think I don't think that when it comes to database that you can ignore a unique identifier. So what if someone wants to retrieve their record, right? So how do you identify that this person called Silvia Bassi is different from another person called Silvia Bassi, right? Because people name can be the same. I've seen someone that bears my three name complete from beginning to end, right? But we are two different people, right? My first name, middle name, and last name same, right? But we are two different people. So in that kind of situation, how do we identify me from that person, right? So now that is where ID comes in. So here I want to create an ID of unique identifier of uniquely identifying a particular record. And I want to do this in a way that a SQL model will automatically increment this man. So it means that if I add my face record, I don't even need to specify this ID, right? SQL model should automatically add one, right? If I should add another record, SQL model should automatically add two, and so on and so forth, right? And so on and so forth. That's basically what I want that particular column to be doing. So I want it to be auto populated or auto completed, you could say. So basically, I only need to provide the record for this man. This other man here would happen automatically. So, but SQL model says that in order for that to happen, that this field needs to be optional. So basically, mean that we need to bring in optional, right? So from here, from typing, import optional, right? So optional is what we need here. So here we want to say that the type of this man should be optional, should be an optional integer, right? So I want the type here to be an integer. So optional in a sense that I don't want it to be compounded, meaning like basically I mean that I don't want to be filling in this particular column. But then if I don't put in this optional and then I put this as just int, which means that this column becomes required. So this optional here means that column should not be required. So I don't want to fill it in from my end. I want it to always be empty. That's what the optional is there. But even if it is empty, the type that should even come in there, if there was supposed to be a value, should be an integer. That's basically what that thing there means, right? So I want this column to be optional, and even if something should actually come in there, I want it to be an integer. Now, why do you want this thing to be optional? So that we can always save data without necessarily doing what specifying this place, right? So now here I can now come here and say, okay, at this point I want this man, I want SQL model to automatically fill in this place. So I can add in other requirements. And how do I add in other requirements? So it's similar to Pydantic. The same way we have field in Pydantic for additional variations, we also have field in SQL model for additional variations as well. So here I could come here and say, let this be equals to what to field. It basically means that I want to add more things. So one of the things that I want to add is what is to say default should be equals to none, right? There should be no value there, but then this should be seen as what this should be seen as a primary key of what of true. So the moment you specify primary key of true, it means that what that they are telling SQL that in creating this table, I want this particular column to be seen as what as a unique identifier, right? Please, you can only have one primary key for one table, right? If you have more than one, then that table is seen as a composite table, right? So that is more like in-depth of SQL model, but I don't want to go that deep to SQL, right? So, but then for now, just know that each table should only have one primary key, right? One primary key. If you have more than one in SQL, that table is seen as a composite table, which is another explanation for another day, right? Okay, so please keep that in mind. So this is basically what you want to do to make this place to be auto-populated by SQL model. Meaning that this option you don't want to fill it. We as developers, we don't want to fill it by ourselves, right? But I want it to be filled by SQL model. So basically, what I set it as primary key, right? And I leave it as integer. Please, this must be an integer because it's easier for SQL model to be able to increment by one. So if this is a string, it's difficult for us to know in what order should we order this thing, right? So please, that must also be integer. So this thing is like a logic, okay? So optional mean that we don't want it to be that we don't want a SQL model to forcefully ask us to fill in that value, right? But then even if we were to fill in a value there, it should be integer. But at the same time, I want it to be seen as a primary key. So basically, I'm telling SQL model if I don't fill it in, do what increment the previous one by one and do what and fill it in there and so on and so forth. Are we following? Please just confirm that we are following.
Yes, sir.
All right. So that's basically how tables are being mapped. So each attribute in this table is seen as a column, right? And the class as a whole is seen as as a table, right? So it's just that simple. It's just that simple. Now the next thing is to now go and connect to the database that we want to somehow write this SQL, because at the end of once you write your script, this man here should evaluate to an equivalent SQL code. So that code needs to write that instruction to a particular database. So that means we have to go back and and connect to that database. So let's go back to our database. Let's go back to our database connection. Let's go back to database connection. So let's go back to here, database connection. Right, so database setup. So what do we really need in this file? The only thing that we need in this file is to connect to the database. I think that's basically all. That's basically all we need to do to connect to a database. So let's go back and let's see how this can be done. So to connect to a database, we use what we call a create engine function that lives in SQL model. So I can say from SQL model import create engine. So this is the man that handles a database connection, right? That's the man that handles database connection. Right? It's a very fantastic. It's a very simple function that just takes in what your database URL, right? So like I said, remember, once you create a database, you get credentials. So the credentials can come in as a single values. So either as the database name, the host name, the password, and so on and so forth. Or you can get a single URL that encompasses of all those things, right? So your database credentials will likely come in two forms, either as a single values or as a straight URL. So in this man here, this man takes in the URL. But even if you are given the credentials, you can use that credential to do what, to create the URL. So the URL is the URL is made up of what, of the credentials. So if you simply Google what makes up a Postgres URL, so let's say what or should I say Postgres PostgreSQL URL format, right? URL format. Right, so you see that that this URL is comprises of basically those credentials, right? So it doesn't really matter in how this information is being given to you, right? So you can see it here, right? So this is the how URL or how should I say, this is how a Postgres URL looks like, right? So if you create a new database, you likely get the username, right? The password, the host, the port number, and the database name, right? So you can carry those credentials, right, and form this URL, right? This is Postgres URL. So wherever you are getting your database from, they will either give you a single URL like this, or they'll give you in separate values like this, right? So basically, what you do, you just simply come here and do what, and replace them, right? And you're good to go. So regardless, you just do work with it, right? Just work with it. But this man here takes in that URL, right? So it takes in the URL. So no matter what you're doing, you need to pass in the URL to that man, right? So if they are being given a single values or a single values, convert them to what form of that URL. Okay. So yeah, I will assume that this will be my database underscore URL, right? So my URL here would be, so like I said earlier, we'll be using the SQLite file system, right? The SQLite file system, right? So basically, we can just come here and create a file called database.db, and that's what, and that is your simple SQLite, right? But then when we want to move to production, we will change that file, right? We will change that file, or we can come here and write a conditional statement that handles how that file should be rendered, right? How this database URL should be rendered. So, but then for now, let's see how you can work with the SQLite file, right? Let's see how you can work with SQLite file. We can come back much later and do what, and put in some functional statements that should order which file or which URL, which database should be used and which shouldn't be used, depending on the environment, right? Depending on the environment. So for now, I will just create a very simple SQL URL file. So remember, every database passed to this man needs to come in a URL. So the URL, if you look at, each of these URL is unique to the database. So for Postgres, it starts with Postgres followed by colon followed by // right? So but then for MySQL also start with what, MySQL followed by colon followed by // Same thing happens with SQLite. It start with SQLite colon // But since SQLite is a file, the / is 3, right? So that's just the difference. Each of these URL has their unique means of representing them. So for SQLite, you simply just say SQLite, okay, colon // because SQLite is a file. So in this case, what follows again is what is the file name, which in this case I could say KodeCamp. I could call this KodeCamp.db, right? So this will be the file. So, but don't worry, if this file is not available, Python will automatically create that file for you. So you don't have to even go and worry about creating this file, right? So you can leave it as it is, right? So if the file is not there, Python will automatically create that file for you. So don't worry much about it. And that is our SQL. And that is our database URL. It's that simple, right? It's that simple. But then once we move to production, so our URL will likely look like this. Maybe Postgres, right? Postgres, and then colon // followed by some very long string, right? So this is already very long, right? So that's basically how it will look like when we move to production. So now that we have our database here, now we can establish the connection, right? We can establish the connection. So how do we establish connection? We simply just say engine. So I'll call this connection, right? Connection should be equals to what? Create engine. And this man takes in what the database URL. This one takes in what the database URL. So it's that simple, right? It's that simple. But though this one takes in other kinds of parameters like the connection argument and the complexity code and so on and so forth, right? But then the required thing is what is the URL. Remember, I said that this man takes what it takes in the URL. So this man takes in URL, right? So, but then because we are dealing with SQLite, SQLite has a problem that doesn't support multi-threading, right? That is the problem with SQLite. But we can alter that behavior by default. It doesn't really support multi-threading, right? So that is the problem, or that is the problem with SQLite, right? So, but then we can alter that particular behavior. This alteration only works when you're using when you're using SQLite, right? But once we move to Postgres, we don't need to put in that alteration because by default, all these high-level databases like Postgres and MySQL, they support multi-threading, right? So, but since this man here is just a file database, it doesn't really support that by default. So we have to do what? We have to turn on that support, right? So we have to turn on that support. So how do we do this? We simply come here. So we simply come here and then I will just call this configuration, right? Config, right? So this config works because we are using this config because of what? Because of this database here, right? I'm not use it when we get to live production. I'm not use it. So this man takes in a dictionary, all right? And the dictionary here has to be what? Has to be check same thread. So this name has to be exactly the way it is. So check same thread. So this is what we want to deactivate, right? We want to activate this man and change this man to what? To false, right? So this one, so from here we can do what? We can pass that this configuration to what? To the args connection, right? To this particular argument here, and connect argument, connect this man here. So connect args. So this was what? Config, right? That is basically what we want to do. So please, this additional configuration here, right, is because of what? Is because of the SQL file, of the SQLite file that we're using for database connection. So that is basically all what you need to do for database connection, right? So that is so that is basically all what we want to do for this configuration using data SQLite, right? But keep in mind, once we migrate, we will not have this man set up, right? We have to take out this man, right? We have to take out that man. But then this will establish the connection to our database, and from here we can do what? We can start interaction, right? From here we can start interaction. So that is basically all. This is basically all. All right. So now what we want to do next now is what? Is to let Fast API do what? It is to tell Fast API, okay, now that we have our table, we have our database set up, please, each time we start use up, like each time we start up the server, please go ahead and do what? And create this table. That's what you need to do, what? To let Fast API to do. So let's go back to our main.py. So coming to main.py, let me just shift this man down. Let's shift this man down the way down. So our main.py still looks neat, right? Our main.py there still looks very, very neat. sorry about that. Hold on. All right. So let's go back and let's start the connection. Okay, or let's let Fast API to do what? To create that table. So to create this table, there is a special function that creates table. That function still comes in from SQL model. So remember, the first one is you create the table, right? And then you do what? You connect. You do the database connection. Now the final step is what? Is to let Fast API know that we now have database. Please, each time you execute, or each time the server comes up, please check if we have any new table you create. If there's no new table, don't create another one again. That's basically what we have to let Fast API to do now, right? So now what do we need to do? It's simple. We need to bring, because this table needs to be created or needs to be mapped to a particular database. And that database can be found in our connection here. Remember, this is the man that holds our database connection, right? So that means we need to bring that man to main file, right? We need to bring that man to main file. So here I can say from dot database setup, I need to bring in connection because that is the man that holds the connection to our database, right? And the next thing is that I want to create a function. I want to create a function that should be creating this table. So here I can call this a function. I can call this def create. This is just our normal Python function, right? Create database, right? And tables, right? And tables. Right, so I would simply just say create tables, right? I would simply just say create tables because basically we're not really creating database, right? Except except we are using SQL like that. Let's just use that. Let's just use the name. Create database and table. So this man is a normal Python function, right? But then we need it to be here. Remember, we said that the utils is what we will use, right? The utils is what we will use to put our normal function. But this particular function is somehow tied to this fast API, right? To this app here, this instance of fast API. Remember, I said that anything that requires the instance of fast API itself should then can then be bring into to the main.py file, right? So this function would be somehow be tied to this instance of fast API. So that's why we need to bring it here. Okay. So this function is a normal function that will simply just create all the tables, right? So we need to also bring in the SQL model because SQL model is what we use to create those tables. So I would say from SQL model, import SQL model. So from SQL model, need to import SQL model, right? And then within the SQL model, we have a very special function. A special function called create all that lives in the metadata of this SQL model. So basically, what am I mean? Or what am I saying? I'm saying that if I should say SQL model there is metadata, right? So there's a function called create all. That create all lives in the sub package called metadata. So that means I need to pass from metadata to get that create all function. So this is the function that I want, right? This function lives in metadata and it lives in SQL model. That's basically what I'm trying to say, right? So this function is a special function that lives in SQL model, and its job is to start doing what is to start writing all the equivalent SQL model for creating tables, right? So all the tables that you have in your project, right? This function job is to find all those classes that lives within your entire project, right? That inherits from SQL model and start writing the equivalent SQL syntax for creating those tables. That's basically what that function is doing. You don't have to worry much about it. This function also have the ability to know a table that already exists in that database. So as such, it doesn't duplicate your table, right? So you don't have to worry yourself much about it. So even if you repeat this code over and over again, your tables can never duplicate, right? Because this function has the ability of knowing which table already exists and which doesn't actually exist, right? So then what this function takes is the database. Where am I writing that SQL model to? Which database am I writing it to, right? So that is where our connection comes in, right? So this man takes in the connection. So I put in my connection there. So it means create all those tables in this database here called connection, right? Are we following? So that's basically what we need to do. So, but then we also need to execute this function only when our server is up and running, right? So there is how we can know when our server is up and running, and how do we do that? So from the instance of fast API up there, I can simply say I can create the instance of fast API has a special function called on event, right? So this on event is a special function that should do something, right, when something happens. So the event type is what we put here. An event type is what is a string. So the event type that we want to put here is the event type that is called startup, right? So startup means when our server is up and running, right? So basically, I want to invoke this function. Remember, I want to invoke this function. Only invoke this function that I'm creating now when we have a special event, which is when our server is up and running. Do what? Invoke this function. So this function here is what we call that function up there. Are we following? So here I can just come here and say I can just call this function on startup, right? On underscore startup, right? Sorry, start up, right? And then here I could just it's gonna be an empty function that does nothing. So here's a normal function. This function just carries a declarator that says only invoke this function when this event has happened, the event of turning on our server, right? The event of turning on our server. All right, and then basically what do I want to do? I want to invoke this function that we have up there. So when this happens, invoke that function that creates our tables, right? That's basically all. All right, so that's that. That's that. And we've successfully set up our database and tables, right? We successfully set up our database and tables. So create the tables when this function is when our server is up and running. And this function is what is this man that does what that creates all tables and create these tables to the database that we have available here, right? And so on and so forth. Question before we execute this code. Question before we execute this code. Right, so I think for some reason why that one event is crossed is maybe it is outdated, but it still works, right? It still works. Even it at some point I even think it is something related to either VS Code, right? Because this on events, this crossing of function, right, signifies that the function is outdated in a particular library, right? So here it's saying that this function is outdated in this fast API library. But then if you go to the fast API definition, right, this function still holds valid, right? So that's why we are still using it. But for some reason, VS Code is seeing it as outdated function, but you don't have anything to worry much about it, right? So don't worry much about it. It still works, right? It still works, even if VS Code said that it is outdated. It still works. All right, and Choma, your is up. Ask question. Choma, I'll show you that not.
No. Can you hear me now?
Yeah, I think it's better now.
Okay. I said the Python model that translates SQL, right? You didn't actually mention the name.
Okay, the Python model that translates to SQL, right, is this man, is SQL model. This is the man that handles all that.
Oh, okay. Okay, so next, my other question is in the schema, right? Because right now the schema and the what's it called? The model is looking quite similar. Although you said the model is just to help us do our tables, right? Create our tables. So does that mean that the schema is actually to validate what we're getting from the front end, and then the model is used to update our database or response or something like that?
Exactly.
More light.
Yeah. So basically, what happens is that the model is what we will use to store data in our database, right? Also validate what goes into the database, right? Remember, this model also comes with validation, right? So it validates what is going to go into that database, right? But the schema is basically meant to validate whatever we are getting from the front end, and we also validate whatever is leaving the response or going back as response, right? So basically that's just the difference. The schema is validating what's coming from front end and what goes to front end. The model here is what is to save, or yes, is to save or is to create table that we use for data manipulation, right? That's basically just the difference. So one inherits from SQL model, one inherits from base model.
Okay, thank you very much for that. Next, this in the main.py, this creates DB and tables, right?
Okay.
Would it not still work if we take that function to our utils, right? And then call it from there,
It will
like
still work,
from util.
of course.
Yeah, because I don't think there's a need for it to be there.
Okay. So we can just cut this man there and just bring it here. Of course, it will work, right? It will work. So I have to bring in our necessary libraries, which is these two, right? And bring into utils. Okay, so bring the man there. So let's see. So I think we are importing from reference, yeah. Okay, so it's working as expected, and then from here we could just simply import it down here. So we could just say from our current directory, utils. I want to import this man, called create database, and that's right. So that was still work. I think this is even better. Okay.
So like we actually treated this. I don't know if you're going to get around treating it, but when we want to like maybe okay, that's in routers. I think you've already covered it. But like you didn't actually show us a situation whereby we're actually calling classes from the schema into our router because we need it there.
Yes.
I don't think we did that in the last class.
So I did that. So here is I brought in this schema down here, right? So I said from schema here, and I did the verification here, or should I say the validation there? Yeah.
Okay.
So that
I'm not lie. I'm still trying to catch up. It's a fast class, but the previous cohort, their classes on database digital tutorials that are available. It's similar, right? Like we can also watch other cohorts, right?
Yes. Okay, no, I think for other cohorts, I made use of SQL Alchemy. Yeah, by then SQL model was not in existence. SQL model just came in newly from the same team that owns Fast API. Okay, so they just brought out SQL model newly. So it'll be the same file structure, right? But the difference is that I'll be using SQL Alchemy there, but it will likely be the same file structure. Right?
Okay, let's make my end up confusing ourselves. I don't even got you. Thank you.
All right. Any other question? Right. So I think someone asked a question on the chat section. So okay, say that doesn't really understand the create all connection, right? So the thing is that right now we've created our table, right? Our member when dealing with relational databases, information is stored on is stored on table. So every other manipulation that needs to happen to that information needs to happen on a table, right? So that means without the table, information can be safe, and if it's not safe, we cannot still manipulate, right? So everything is still hanging on table. So and I said that this is how tables are created, or this how table is meant to be created with the help of what with SQL model, right? Because if you don't create it this way, then it will be considered as our usual Python classes, right? So there will be no mapping. That ORM technique will not work, right? So for the ORM technique to work, your classes needs to inherit from where? From SQL model, right? But then after this more like the structure of how we want our table to look like, right? But then what happened is that if we don't explicitly now say, okay, fine, we finished this structure, go ahead and do what and map that SQL and go ahead and start writing that SQL syntax for this. It will not work, right? It will not work. So it will just be there. This structure will just be there, right? But then the table will not actually be mapped to your database, right? So now the job of that create all function, right? The job of this create all function, right, is to go ahead and do what and explicitly collect all the classes within our project that is inheriting from SQL model and do what and write the equivalent SQL code for it, right? So go ahead and do what this is more like saying go ahead and start mapping, right? So start replicating these classes to an actual table on the database, right? That's basically what that function is doing there. And because this function is to start replicating those classes to a table, right? So we need to know which database are we replicating it to, right? So that is where this connection comes in. This connection is a variable that holds the connection that we make to our SQLite database, right? So without that connection, we cannot map, right? Because even if you want to map, which database are we mapping it to? Because table needs to stay inside database. So database houses tables stays inside database, right? So now we want to create the table, but then where are we creating the table to? Right, so that is what is happening here. So this connection here is coming from where? It's coming from database, where we establish the connection to our database, right? So now we now pass that connection to our create all function that will now go ahead to start creating that table. But we only start creating this table only when our server has come up, right? Only when our server has come up, right? And the good thing about that function is that even if you end your server multiple times, you end and open, end and start, right? It can never create multiple tables, right? So it knows all the tables that are available in that database. So basically what happens is that if that table already exists, then it will not create again, right? So that's just the good thing about this man for create all. Is that understood? Mr. I think that was Gabriel. Okay, Gabriel. Is that understood, Mr. Gabriel? All right. Okay, so now let's go ahead and let's test out our server. So fingers crossed, hopefully everything should work just fine. Everything should work just fine. So let's go ahead and let's start our server. So how do we start our server? So remember, we have to stay outside of our how do you call it? We want to stay outside of our app, right? Outside of our package folder, so we cannot invoke it inside again. So I'm outside already. So I'll just say ubcon, and then app.main, and then colon app, right? So that should invoke this man. So at the moment I execute this function, our table should start creating, right? But so far we have just one table. So this table should just start creating, right? Which has happened, right? But behind the scene, it looks as if that hasn't happened, but that has happened. Okay, so let's see if I can find that file. The thing is that this man will somehow end up creating that file outside of the app itself. So let's see what happens. Let's go to where? Let's go to our. If you come here, so you can see it. So this is what we are having, right? This is what we are having. So this is the problem. It will somehow create this file outside of I think it's because of I don't know, probably the directory that we specified. So I think we can always specify a good directory there, right? But by default, it will always create this man outside of a package folder. So this is what I want to do, right? So the thing here is that I don't have any program or any software that can open up that file, right? So I don't have any database software that can open up this file. But if you open up this database file, then you see you will see our data table, right? The tabular form of it. But I think if you download, there's an extension or there's a software. But I think if you Google up, if you Google up, how do you call it? Software for SQLite. I think I think you should be able to see a software that you can. Okay, so this is it. So you can download this man, right? And you can do what? And you can visually view your database, right? You can visually see the table, right? You can where you see the tables themselves, right? So just download this man. I think this man works. So you just go to sqlbrowser.org. So this will give you an application. You can just download it, right? And so here you see it like this, right? You would see it in this kind of form, right? So which will make a lot of sense. So you can just do that and then use that app to open up your database file. But for now, we cannot open up that database file. So, but then this is what I want to do, right? This is what I want to do, so that this is what I want to do. What I want to do. SQL model from, okay, so simply just say pip install SQL model. That will have SQL model installed. Right, so this is what I want to do, right? This is what I want to do. Yeah, just do pip install SQL model. That will work for you. All right, so this is what I want to do with our file so far. This is what I want to do. Please just hold on, guys. I want to move this man. I want to create another folder and then move our app inside there, right? So that we just have everything kind of enclosed. Okay, so let me do like this. Where is it? Where are we? I'll open up this one. And what I want to do is I want to create a folder again, right? And this folder, I want to call this project, right? So this project folder is, and then I'll just cut our, let me see if I have my VS Code open. So please, okay, so it's closed. Okay, so I'll have to come here now and cut this file along with this KodeCamp database, right? Cut it and put it inside here. Okay, so hold on, let's so I think I have to close my VS Code first for that to work. Okay, so let's try again. All right, so we have that now available there, right? So that's what I want you guys to also do also. Just put these two things inside this folder, right? So that we can just have everything. So I'll delete that other data without again, but I'll put another one, right? So once we go back again to my command prompt, I can just navigate to project, right? Because that's where we now have it. So to project, and I can open up project in VS Code. All right, so that once we create this man, it just stays there, right? So that once we create this man, it just stays there. So that we can just view the database file, right? So this is basically just for viewing that database file. Okay. Second time. All right, so while that is coming up, let's go ahead and let's execute our file again. We should now create another database. Remember, if the file is not there, it will just create the database file. Right, so I have my app there. So this is our app here now. So our app is not there. Hold on. Throw this man out. Okay, so I have our file there. We have our main. So let's go ahead and let's run our server again. Once we run our server, we should have our database file now outside our package file. So somewhere outside here, right? So let's go back again. Where are we? And go ahead. Let us go ahead and execute again. So ubicon app main dot app again. Okay, app.main :map app. Right, so let's go ahead and execute. Right. So we have our KodeCamp there. So okay, that's fine. That's what we wanted. So we have that now. Everything is good to go. So believe it that our table has been created. Right, our table has been created. But even if we can't visually view it, but just that our table has been created, and of course we can create as many tables as possible. Right, we can create as many tables as possible. So now let's see how we can do some CRUD operation. So let's quickly see how we can do CRUD operation, and then we can wrap up, because I think we are already running out of time. Please, tomorrow we have to meet. Please, is non-negotiable. We have to meet tomorrow, 11 a.m. Please, I'm pleading with us. Please, let's meet tomorrow, so that tomorrow when we come tomorrow, we do what we see how we can how we can add some information to our documentation. Because once we move to capstone project, right? Once we move to working with front end guys doesn't want to see our code. They don't want anything. The only thing they want is what is seeing is documentation URL. So it's sending that URL and they're good to go, right? So you come and see what we can add, how to add valuable information to the auto-generated documentation, and then see how we can deploy, how we can go live, right? How we can go live, because it is essential. We cannot go live, or we cannot share the URL if they are local. So please, that's what we will do tomorrow, and that will be the end of our classes, right? That will be the end of our classes. Please let it be by 9 a.m. please, same time that we met today. All right, so please, so that will be the end of our classes. Once we meet tomorrow. Next time I meet again is mostly in group meetings, right? Where the most will call me, sir, come and see you. Tell me I'll come and go and see. I will just see because it's what come and see. I'll just go and accept that, okay, if I do well, do that. Okay. So that's basically what will happen. All right, so let's go ahead and let's carry out some, because remember that's what you mostly do, code operation back to back. It's either you're creating something. So when I mean creating something, it mean what I mean that is either you're adding something to database, you're updating it, you're deleting it, or you're create, read, update, and delete. So that's basically all the things you will likely do in database, right? When you have database or when you have tables available. So let us see how we can create or how we can add something to a database. So, right. So let's start with some crude operation. Let's start with some crude operation, please. So crude stands for what? Create, read, and what? Create, read, update, and delete. So like I said, we only focus on what? On two things, on two requests, the get and the post. Right. So I don't want to go outside of those two requests, right? I don't want to. If it's delaying, just do Control C. I did Control C and miraculously it worked for me. If you go do your own Control C, you stop. Oh no. All right, so let's do some crude. So basically, I want to have a crude here. So crude is going to be what functions that will interact directly with our database. Please, are we together? So crude will be function that interact directly with database. So either we are creating something, basically adding something to a database, we are updating, we are deleting, we are retrieving, right? So let's see. What do I want? I want to create a new file again. This file now would be user management, right? So user management crude would be interaction pertaining to what to user management. Am I making sense? Right. So that's basically what will happen here. So let us see how we can do some crude. Right. So let's see what we can do. All right. Okay, so to start interaction, one thing we should know again is that to start interacting with database is something that we need to keep in mind. So the same way we have the create all function from SQL model that create all table, we have a special function called session. Now, session is a function that helps us do what? Interact with database. Without session, we cannot interact. It's one thing to create the tables. It's another thing to do what? To interact with the table that have been created, right? So that's basically what you should know. One thing to do what? To create the table. It's one thing to interact with the table. So the create all function, create all the tables. The session function allows what? Interaction with the tables. And by recommendation, it says that for every interaction, there should be an opening of session and closing of session. It means that if I want to add a file, if I want to add a new record now to my table in the database, what do? I have to open this session, add the record, and then close the session. Even if same thing happens if I want to do what? Update, open again, update, and then close, and it keeps going like that, right? So it keeps going like that. So let us see how we can achieve that. Let's see how that can be achieved. Hold on. Hold on a second. Let's see. All right, so let's see what can be done. All right. Basically, we want to pass in session as dependencies, please. So basically, what happens is that the best way of opening the session and closing it after every interaction is to pass it as a dependency. So it means that if I pass it as a dependency before the request comes for the interaction of that database, I've opened up that session first, right? Because the request has to pass from dependency, right? So that means before it comes, session has been opened. Basically that session function, I want to make use of what of yield. So what happens is that once the response is sent, fast API will automatically close that session again. So that basically that will be the flow of that session. That will be so okay, you're asking if we cannot create all if we cannot create all the tables inside the models.py. Yes, we can create all the tables inside models.py. Of course, you can create everything inside here, right? You can create everything inside this file, right? But maybe for classification's sake, right? Let's say there's something wrong with plugging, right? So assuming we have like 1,000 tables, it's not be funny for us to be scrolling down 1,000 tables just to find a particular table that needs an update, or a particular table that needs a problem or that needs fixed. Okay, so that's why I'm splitting it. So where each section of my code or of my software has their own files. So there's a section for user management in the CRUD, there's a section for user management in the model, there's a section for user management in the schema. So we know that if there's anything wrong with user management, right, I know which file to go to, right? So that's why I'm basically just splitting all these files in separate files. Oh, sorry, why I'm putting all these things in separate files. Okay, but you can, of course, you can choose to put it in one file if you want. There's nothing wrong. Okay, so let's see how session will come in, and let's do some CRUD. So basically, someone also asked that doesn't know what CRUD means. CRUD means CRUD is basically is more like file manipulation, right? So when you're manipulating a file, 4 things will likely happen, or 4 things is likely going to happen. So it's either you're creating a new file, right, or you're updating a file that already existed, right, or you're deleting a file that already existed, or you're extracting information from a file that already existed, right? Now all those things now is considered as file manipulation, and can be abbreviated as CRUD: create, read, update, and delete. So now how do we do all these things with database? Because that's basically where all our interaction will evolve around. All interaction will likely be either of those 4 things. If you're not creating, you are reading, or you are updating, or you are deleting, right? So that's basically what CRUD is, and that's what you want to actually look at. And like I also said, that CRUD, right? That CRUD is also what? CRUD is also is session dependent. So each interaction needs to come in, needs to depend on the session. So I'll come here and I'll create my dependency for sessions. Right? I'll come here and I'll create my dependency for sessions. Dependency, okay, let's see. Session. So let's come here and let us see. So I can come here now, I can have my own dependency here. And I'll call this man get session, right? So basically this is a function that I want to call to do what? To open and close session, right? To open and close session, right? To open and close session. And then I want to use this special word called with, right? Remember we use with when we're dealing with files, right? So same thing is happening here. We want to use with when dealing with session. Since session is also similar to file, as it needs to open and close, right? As it needs to open and close. So I would say with session. So basically, I want to invoke the session. So I have to somehow bring in session, because remember, session is also a special function that lives in SQL model. Same way we have that all, right? So session is meant to do what? To grant interaction. That's basically what session is meant to do. So I would simply just say from SQL model, I want to import session. That's the man that we want for this ministry, right? So I'm simply say with session, right? With session. So basically, open session, right? As session, right? As session, right? So basically, open this man has to be invoked, because and this man also takes in the database connection, right? The database connection. So if I'm going to grant you access to interact with database, which database am I going to grant you access to, right? So that's basically what this man takes in. So that means we have to somehow bring back our connection, right? So that means our connection is also needed when creating tables. Our connection is also needed when establishing sessions, right? So this man here is needed here. So I have to come here and do and bring that man in. So I will say from dot the database setup. I want to import session. Sorry, not connection order. And then pass this man as connection here, right? And then at the end of it all, I don't want to return, right? Remember, this function needs to return, right? But I don't want this function to close immediately after that session after that that dependency has been invoked, right? I want that I want fast API to come back and close this dependency, right? So what I will do is instead of using the return, I'll use yield. So yield is what I will use, and I want to yield what this opening of this session, right? So this invocation, this man here, right? So I am saying invoke or open up this session, right? As this. So that means I want to see the session property or the invoked session as session, right? The lowercase session there, right? And then I want to yield that. So it means once the request goes to the route that needs to interact with database, right? I need to invoke what this session here, right? And use it for what? For interaction. Thereafter, I can do what? I can, once response has been sent out, what happens is that fast API will automatically come back and do what? And close that decision. Because what? Because we are using what? We are using yield, right? That's basically what happens. So that happens by default. I believe we are following up to your point. Please, are we following? I believe we are following. Yeah. All right. So okay, so let's go back. Okay, so let's proceed. So that is our dependency that we want to use in our route. So let's go and let's see. Let's go and let's see. So I'll go back to our to one of our CRUD, right? Let's also go back to one of our CRUD here. I thought we had CRUD here. Wow. Okay, we don't have any CRUD. Okay, but we have router. Let's go to router. Remember. All right. So remember, our router is what is where the request goes into. So let's say if someone wants to sign up, it means do what? Send your request to what? To, let's say we sign up. Okay, let's say we have sign up here, right? So that means send your request, your post request to where? To account/register, right? So post request to account /register, and then we do what? We validate what comes in, and then we do what? We pass what comes in to where? To session, and then do what? Add that credentials to what? To our database, right? That basically the workflow. So let's go ahead and let's write the schema for that will validate what is coming in, right? The schema for validating structured data. Remember, I said that any structured data that comes in needs to be validated. So the only thing that can omit validation is what is unstructured data. Something like, let's say, the query parameter or the path parameter. Those ones can skip validations, but as far as it's coming in via the request body as JSON form or JSON standard, they must pass through validations, right? They cannot just escape it. So let's go to our validation. So basically our schema, go to schema, database, schema. And here I want to create the validations for what? For registry. So I'll call this class register. So this is something that we're already familiar with, just that this still now is not in separate files, right? And I'll call this other one here first name, maybe one first name. Remember, our table says first name, right? So your schema will also likely matches your database, right? Because you want to play something that needs to be filled into the database. So I will say first name. I want first name to be string, and I can have second name. I will say last name. Last name, I'll have email, I'll have password, right? I think that's all right. Let's see what we have in our table. So our table says that we have to save email, okay, first name, last name, email, and password. All right, so we are good to go. All right, so let's go back again. Sorry. I think we are good with schemas. Our schema is good to go, right? So now we have to bring it in and use it in our router. Okay, so I have to come here and put comma, bring in register, right? And then here I could just say reg should be registered to be embedded by what? By register. Okay, and for now I can just simply return this man. So let's just see. I can just say response should be equals to reg. right? So that we see that this man is working as expected. Okay, so now let's go ahead and let's bring up our postman so we can send in this request. Okay, then we can come back and do the CRUD. So postman, sorry, I think we've even passed our time. So maybe we can just try out this at least create, and then we can come back tomorrow and continue from where we left off, right? So I don't have to keep you guys for long, please. Postman is coming up. Postman. It's coming up. Hold on. Postman is taking enough time. Okay. Right, Osato, your hands up.
Yes, sir. I wanted to quickly ask while we are waiting for Postman, like what is
Okay.
the topic that we needed to cover for tomorrow before we actually get to the capstone project, so that maybe we
Okay,
can read about it beforehand.
Okay, so tomorrow we are going to look at just going to look at adding information to just put it as documentation, right? Just put it as documentation and deployment, right? Documentation and deployment. Documentation and deployment. So seeing how you can document, add some few things to our documents and then we deploy. All right, show me hand is up.
Yes, sir.
I'm not hearing you.
The CRUD, like
Sorry?
nothing. The CRUD, the create read. You've not done anything. At least I'd like to see something on it.
Okay. Okay, mean the CRUD, yeah, that's what we were about doing, right? That's what we are about doing. Are you there? You see there? All right. I think we've lost them. Okay, so basically, so we want to do what we want to send in the post request to this man here, right? To account/register ports for a user to want to be registered in our database or to be saved in our database. So but the thing is that the truth is that most requests that comes into your endpoint will likely interact with CRUD, because I think most requests is either each request is either creating or reading or updating or retrieving. So keep it in mind that all your endpoints will do CRUD. All. At least it will do. At least there will be at least one CRUD. Probably is an endpoint that needs to get that needs to send email, or endpoint that needs to get OTP and all those things. But then even with that, you still CRUD. Almost all your endpoints will be doing CRUD operation. All of them. All right. So let's go back and let's see. So I have my postman set up. And let's go ahead and let's send in that request. So the request here is I need to pass in. I need to submit my first name, last name, and email alongside with password. So I have my first name. Sorry, my first name. First underscore then. Yeah, we just say test user one. So I'll call it test. And last name. Last name. I'll call last name user one. Right, and then I'll call email. And I will call this man how do you call it? So call this man, let's test user at gmail.com. All right, and the password, of course, and the password here will come in here, and this will be like password, and this will be like password. All right, so let's go and let's see. This should be password. All right, I think we are good to go. So let's go ahead and let's confirm that. Let's confirm that our server is still up and running. Right. So let's update this one. Okay. So from here we just send in the request. It says last name is missing. Oh, this should be last name. Last underscore name. So send again. So we have there. So our response went through, right? But then by default, certain things needs to be saved, right? So at this point, we need to collect this response, right? And do what and save it to our database, right? So that is great. The C, that's CRUD, right? The C part of the CRUD. So now how do we do this? So what I want to do is I want to go to CRUD, right? And I also want this man to be seen as dependency. So I need dependency somewhere. So I think we use dependency somewhere at some point. I think can't remember where, but I think we did use dependency. Can't remember where exactly, but I'm certain that we use dependency. 100% certain. Wait, okay, we used this way. Where was this used? In a route, I think. Block. Yeah. All right. So let's go ahead and let's do that. Okay. So let's add let's bring in dependency. Right. Let's bring in dependency. So I will say from Fast API, we have to import depends. Right. What we want to depend here is what is our session. Remember, we need to interact. So I will say from where is that man? This man is available in up dependencies. Need to import. I need to import how do you call it? Need to import session. I think let's see. Hold on, let's see what's happening. You need to import get session. Yeah, you need to import get session. Right, and then this get session, we have to pass it as dependency now. So I will say session is equals to depends. That takes in what they get session, right? So this man here will invoke that function, right? And we in turn we will get what? In turn we will get the open version of this session, right? Where we can use for work for interaction. So then at this point here, I can then do what? I can then further, where are we? Can then further pass both the data that needs to be saved and the session that needs to be used for interaction with our database to a function. So I will call this function a create user function, right? Create underscore user function. But now that function does not really exist yet. But basically, what happens is that I will pass both the data, which is what rec, and the session, which is session here, right? So this function I need it to be available at our CRUD. So I would say from. So we have I would say from CRUD user management. So I want to import this man called create user, which at this point is not yet available, right? So I'll come here and paste, and then I'll come back here, and then I'll just simply create this function here called def creates user that takes in both data and session, right? And for now we leave it as pass. All right. So please, I want to be sure that we followed up to this point. So this is me creating. So this is the function that will carry out the CRUD on our database. So this is a function that will create or that will add a new record of user to our user data table, right? So that this function is available in the user management of CRUD, right? And then I've imported this function to our router, where I'm saying once a request comes in here, because this function takes in both the data that needs to be saved and the session for the interaction. So here I'm saying once the request comes to this router, right, get the data, which is rec, and also get the session as from dependency. So pass both the rec and the session as to that create user function, which was then imported from there, right? So now once I come here now, and I'll now know that my data here is rec, and my session there is the actual session from the dependency. Does that make sense? Okay, let me open the block. Okay, so your block is nothing, right? So your block is just like, I think I use the block to let us know that we can have multiple instances of this man, right? We can have multiple instances of that man, but we can have multiple instances of fast API. You understand? Is there a question? Can we continue? Is the class too fast? Can we continue?
Yes, sir.
All right, let's continue. So please, I know that we are already exhausted, but let us let's look at it, even if just creating, at least they see. When you come back tomorrow, we see how you can do the R, the U, and the D, right? So which is pretty simple, right? So to create a user, right? To add a record to a database, we do what we simply create the instance of that class, right? Alongside with the attributes and their values. So what do I mean? Let me see what I mean. So, excuse me. To create a user, right? So basically, what you want to do is you want to bring in our class, right? So where am I adding this record to, right? So this record, I want to add it to our table, right? Our table that is available in this model, right? So I will say from model dot user management. I want to import our user table, right? So that is the man that we want to add that man to, right? We want to add that man there, right? And then how do we now add this man? How do we now add a record? So to add a record, I would simply you simply invoke the table. So basically, when I mean invoke, I simply make an instance of that table, which in this case, this table, right? So basically invoke that table like this, right? And then within this table, you know what? You pass in all the attributes, right? All the attributes that was defined in that table, right? So basically, you specify the column alongside with the value that should fill it into that column. Only leave the column that was left or that we say that it should be optional. But every other column that we not specify that it should be optional will be required, right? So that's how you create a new that's how you add a new record, right? But then so now this high level instruction now will be mapped to equivalent SQL command for adding a new record to a table, right? So here I'm saying that we have the first name attributes. So basically everything that we have here. So go back to our table. So everything that we have here that we've defined so far, I'll copy this man down here. So I don't have to move up and down, right? So I'll just come down here and then just paste it there. So it means that I have to provide the first name alongside with the value of the first name, right? So what will be the value of the first name? It will be fine. It will be derived from where? From data dot first name. I hope you guys understand how I'm getting the data from dot first name, right? Because remember, if you go back to our router, right? Our router here is saying what pass the data. So this rec is seen as what as data, Abi. So now how do I get the value that? Remember that if I should print rec, which is what if you go back to router. Remember here I said show rec. If you go to Postman, it basically showed everything, right? It showed everything that we have here, right? But then if I want to get a single value from that response, I will just simply say rec dot first name, right? And I'll get this value of first name. Am I making sense?
Yes, sir.
I'm confusing us. Gabriel, don't they shout. Or should we stop here and then I'll let us go and rest. We come back tomorrow. We pick it up from here. Let us go and absorb this one that we've done so far. When we come tomorrow, we pick it up from here and continue. All right. So I will stop here. Okay. When we come back tomorrow, we continue from crude, please. Please, tomorrow, let's try and come on time, right? Let's try and come on time. Let's come on time, right? So I'll leave it here. Let's not go far again. I'll leave it there. Okay. And when we come back tomorrow, we continue crude. Okay. But any other question outside crude? Any other question pertaining to the database connection, table creation? I think that's the two things that we've done today. Yeah. Mr. Chome, your hand is up.
Yeah, please can you throw more light on the logic behind this section, how it works,
Okay, session.
please?
All right.
Yes.
So where is that session? So session is supposed to be, you know, I want us to make it go. I want us to send me shot again. All right, so let's look at session. Sorry about that. Okay. Session, where are now? Where are that? Where are that? Where are that? Okay, so session is here. All right, so basically, what is session? So, like I said, these are, we have some special functions that live. Remember that SQL model is the parent model, or is the parent library that helps to do what, to interact with relational database. So be it in interaction by creating a table, or by connecting to the database itself, or by even interacting or manipulating what data on inside the table, right? So SQL model is what is the mother package. Right now, within this package, we have some special function that helps us in doing each of these tasks, right? So the first function we looked at was the create all function, which is specifically used for only creating table. And like I said, it's one thing to create table, it's one thing to start interacting with that table. So by interaction, I mean what? CRUD. So it's one thing to do what, to add data to that table, update a data in that table, delete the data from that table, or fetch the data from that table. So that's the interaction. So one thing is to create, one thing is to interact. So create all is a special function that creates the table. Now session, on the other hand, is a function that does what, that allows interaction. That is CRUD, right? So that in order for this session to allow this interaction, this session needs to do what? Establish a connection with the database, and then before that interaction can happen, right? Now after that interaction has happened, that session needs to close that connection with that database, right? That session needs to close that interaction with that database. So there's no point of still maintaining that connection after interaction has been done, right? According to Fast API. So now what do? We simply create a function, right? Of course, even without this with, right, this will still work, right? If I should just simply just say, come here, and if I simply just say, if I simply just, okay, let me just replicate this, right? Let me replicate this, so that I think if I simply do this, right, and then I say, let's session equals to this, right? Let's session equals to this. And then at the end of it, and answer a yield session. This will still work, right? This thing here, right, is the same thing as this, man. All right, this thing up there, right? So here, but the only difference is that we are now using this with for additional security. Because remember, by default, if remember when we are dealing with, right? I said that with we can do what, we can open a file and forget about closing it, because the moment we finish executing all the code within that with, and then step outside of that with, it automatically closes that file. If you can remember. Right? So same thing happens here. The moment we finish interacting, like the moment we finish executing this code within that with, and then step out, what happens is that it will close this session, right? It will close this session. So that is why we now brought in with here, right? So with here we are saying what, and once I call on this function called get session, right, I want you to do what, open up this session, right? So establish that connection with the database. So here is establishing that connection with database, and I want to view that connection as session and not connection again, right? So connection here is what is the actual connection to the database that is used for creating table. But this other connection is a connection that is established with the already connected database, and then provide the platform for interaction. Am I making sense? So this particular connection is different from the creation of table. Right? And this one is what is the connection for interaction. So here I'm saying establish establish that connection for interaction, and I want to view that connection as session. So once you finish establishing that connection, do what? Return it. Not really return, but yield that result that give out that connection. So it means if I call on this function, I want you to give me the established connection that I can use for interacting with the table within a database. Are we together? So now after creating that dependency, now I can do what? I can now be passing it to any route that requires interaction with the database. So if you go back to our user management, what do? We simply sorry, not here. User management. Yeah. So here. Okay. So here I'm saying no, not here. User management router. So here is the route that needs that session. So here I'm saying, okay, fine. Once a user signed up and then sent in their data as post request, right? I want to collect that data while also doing what? While also calling the get session. Remember, the get session is to give me the established session connection, right? And then I can use both that session now, all right, and that data that has been sent in, and do what? And use this session to do what? To add this data to database, which is what? Creating, Abi. And then after that has been done, the moment this route, right, sends out a response, remember this happened, this return happened in this route, right? Then by default, Fast API will go back again. And because this session was yielded, it will go back again and do what? And close off that session by default. Are you following? So session is meant for what? For database interaction, specifically what? Creating, updating, they include aspects. They include aspects. While the other create all is specifically meant for what? For creating tables that will be used for what? For interaction or for CRUD. Make sense?
Yeah, makes sense. But please, can I quickly look at your database setup.py?
Okay, database setup. All right, so there it is.
Oh, okay, thank you.
Okay, any other question? All right, so no other question. Please, when we come tomorrow, we will look at what CRUD, and then we look at what database, documentation. Those things shouldn't really take documentation and set and deployment shouldn't take up to 20 minutes. It's very simple, right? Already we have the auto generated what URL. So just to come and add some few things to that document, right? Just to come and add some few things to that document. Nothing, and then what we deploy, right? We deploy. I think our project folder is almost ready for what? For deployment. Just some few more files that is needed, like the requirement.txt file and so on and so forth, right? So those are the files that is left. Requirement.txt file, git.env file, and some other files that is meant for deployment. .env file and all those stuff. So when you come to where we fix up all those things, and then we do what? We deploy, and then wrap up this bootcamp tutoring aspect. And I will see you guys in capstone phase. Okay, so that is that for today's class. Please do have a very productive day ahead of you guys, and I'll see you guys tomorrow 9 a.m. Please let's come out on time, please. Tomorrow class will be our last class. It will be the last time I will explicitly explain things. The next time you see me, I'll tell you do this, push that one there. Go and Google how to do this, do research on how to do that, and so on and so forth, right? Right. But if need be to explicitly explain, I would. But then it will be on touch mind. It will be on a very good mood. it will be on a very good mood. Apart from that, I'll try to push and do this, do that. Yeah, for slides, please. Hopefully, when we finish tomorrow's class, I'll just stay on the class and just push it and just push to GitHub as well. So we just get it all at once, right? So slides will come in. Slides will come in as well. Okay. Any other thing? I think that's all. So please do have a wonderful day, and I will see you guys tomorrow 9 a.m. Right, 9 a.m. West African time. Right. So bye for now. Take good care of yourself. Bye bye.
Thank you so